Hello everyone, it's indeed inspiring to talk about the concept of regression analytics, which is a subpart of supervised learning that we have already learned. We will start with the basic definition of what regression analytics is. Regression analysis is a powerful statistical method that allows you to examine the relationship between two or more variables of interest. Regression helps investment and financial managers to value assets and understand the relationships between variables such as commodity prices and stocks of businesses dealing in those commodities. From this, we understand that regression analytics is something related to the statistical data and it deals with that. We will understand this even more deeply with an example. You might guess that there is a connection between how much you eat and how much you weigh. Regression analysis can help you quantify that. In what way? Let's find out. Regression analysis will provide you with an equation for a graph so that you can make predictions about your data. For example, if you have been putting on weight over the last few years, it can predict how much you will weigh in 10 years time if you continue to put on weight at the same rate. When we talk about the equation and the graph, we are actually talking about the regression line that we plot while doing regression analysis. The graph is actually a line which is having an equation given by y is equal to mx plus c, which we will look in the further coming slides. Now, we will talk about the terms involved in regression analytics. These are independent variables, dependent variables, regression line, outliers, multicolinearity, underfitting and overfitting. Independent variable and dependent variable are actually involved in the equation of a regression line. The equation is given by y is equal to mx plus c. Here y is the dependent variable and x is the independent variable. When we talk about the outliers, outliers are the exceptions that we have in the statistical data. Multicolinearity is the relation between the inputs that we are providing in the statistics. When we talk about underfitting and overfitting, these terms are related to the plotting of the regression line, and we will see these in the further coming slides. For now, we will talk about the types in regression analysis. The two basic types of regression are simple linear regression and multilinear regression. Although there are non-linear regression methods for more complicated data and analysis. Simple linear regression uses one independent variable to explain or predict the outcome of the dependent variable y, while multiple linear regression uses two or more independent variables to predict the outcome. This is very simple. In simple linear regression, we have one single independent variable, and in multiple linear regression, we have many independent variables. The general forms are given over here. These are y is equal to a plus bx plus u for simple linear regression, and this longer term, that is y is equal to a plus b1 x1 plus b2 x2 plus b3 x3 plus bt xt plus u, is given for the multiple linear regression. We will talk about these terms in the next slide. Now here we have the equation for simple linear regression, which is given by yi is equal to beta naught plus beta 1 x1 plus epsilon I. Yi is the dependent variable, beta naught is the population y-intercept, which tells us from where the line will pass. Beta 1 is the slope coefficient that tells us what will be the angle of inclination of the line. Xi is the independent variable and epsilon I is the random error term, which tells us about the error that are being included in the statistics. Moving on to the multilinear regression, the equation is given by y is equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on till beta n xn. Here rest all the variables are same, just the difference is here are many independent variables. So x1, x2 and xn are the independent variables, and B1, B2 and Bn are the respective slope coefficients. After this, we will talk about what are outliers. In statistics, an outlier is a data point that differs significantly from other observations. An outlier may be due to variability in the measurement, or it may indicate experimental error. The latter are sometimes excluded from the dataset. An outlier can cause serious problems in statistical analysis. When we will look at this graph, we can see that this data set or data point is known as the outlier, whereas these data points are the normal ones. When we try to put a regression line from these data sets, we will find that this outlier will affect the plotting of the line and will actually create problems in giving out the outputs, and therefore outliers actually causes a lot of serious problems for statistical analysis. Now, multicolinearity refers to a situation in which two or more explanatory variables in a multiple regression model are highly linearly related. The correlation between the two independent variables is 1 or minus 1. This means that in multiple linear regression, the inputs that we provide or the independent variables that we provide are actually interrelated. This causes a lot of problems while giving out the output in regression analysis. Here comes fitting a line of regression. That means plotting the regression line. We know here that regression line passes from the maximum number of data sets in a plotted graph. We have here two different terms, underfitting and overfitting. Let's read out the definitions. Underfitting occurs when a model is too simple, informed by too few features, or regularized too much, which makes it inflexible in learning from the dataset. Simple learners tend to have less variance in their predictions but more bias towards wrong outcomes. When we talk about overfitting, overfitting is a modeling error that occurs when a function is too closely fit to a limited set of data points. Overfitting the model generally takes the form of making an overly complex model to explain idiosyncrasies in the data under study. We will understand these terms from this example. Here we have the example of underfitting, which shows that two different types of data sets have been created and the line of regression is passing too leniently, leaving out many of the data sets on the either sides, which creates a lot of errors while giving the outcomes and therefore is not considered as a better option. Now, when we talk about the example of overfitting, this is known as force fitting. That means too good to be true, which means that it also includes all those outliers that we have in a data set, which considers all these things and then plot the regression line, which makes it too complex, and therefore this also creates many problems while giving out the output. The best one is the appropriate fitting, which considers almost all the data sets and leaves some of the exceptions, which gives the appropriate answer and the outcome, and therefore this type of fitting is preferred while fitting a line of regression. We will talk about the applications of regression analysis. This turn out to be the predictive analytics, operation efficiency, supporting decisions, correcting errors, new insights. At the end, we will talk about the summary. Regression helps investment and financial managers to value assets and understand the relationship between variables. There are two basic types of regression: simple linear regression and multiple linear regression. Regression analytics can help in predictive analytics, operation efficiency, supporting decisions, correcting errors, and getting new insights. Thank you so much. If you liked our video and would like to recommend it to your friends, please like, share and subscribe to Indeed Inspiring Infotech. We would also love to hear your suggestions and feedback in the comment section below.